Hello, I'm Cole Kingery, and this is my project as an extension to 3D Common Corruptions and Data Augmentations. The problem we see is that computer vision systems make errors when encountering unforeseen camera or weather corruption, and this is simply due to a lack of data and training them for these scenarios. So that leads to the underlying motivation that with all the systems using computer vision, we need to find a way to increase model robustness through increased data augmentation and providing the data before it is seen out in deployment. Because of this, research needs to be done in creating this corrupted data that models can train on before being exposed to these circumstances out in deployment where they could fail. And on the right, you see some weather corruption and how it really changes how the computer vision models see. And this is the underlying problem and what we aim to combat through more data augmentation. So my implementation, it implemented the 3D Common Corruptions GitHub, and as well as I extended it to my own corruption. So for it, I utilized the Coco dataset and Coco depth maps for the 3D generations. And I implemented the 3D fog generations to see if it would appear as if it's part of the 3D domain and if it is realistic as the paper describes. So looking down below, you see the 3D fog applied, and as we can tell, that bike tire that is much closer to the camera is more visible than the back scene in this dense fog scenario, making it a much more realistic corruption that could train cameras on what it's like to be in heavy and dense fog before they're out there. I also created my own new 3D corruption representing low light noise, and this is done through applying a varying Gaussian noise to an image in 3D. I also make my extension callable in the same manner as the original paper's functions so that it is a valid extension and will expand beyond me when this project's done and can be usable by others in the future. So to evaluate my experiments and my testing, we really just take a visual look at the corruptions and augmentations generated. So we see a realistic 3D appearance in the augmentations like the fog before. We could see the bike tire is more visible, or the background is blurrier as the fog becomes more dense. And so here with the Gaussian noise corruption, we can see the table more that is closer to the camera is clear. However, the background becomes blurrier, has that corruption applied to it, and this is all to make it a more realistic 3D corruption that could have varying distribution shifts when it is run and when data is trained on this. The highlights of my project is that the implementation of the realistic fog corruption for computer visions to train on was a success, and this really correlates to their other functions and other models they feature in the paper, and that they work the same way, so they'll also be successful and look realistic, which is what the paper claimed and which is what I was able to see in my testing. We also want to highlight the creation of this new 3D Gaussian noise that can represent a low light scenario for when the models or when the computer vision system might be in a dark environment. That might not happen all the time, but it's good to have this corruption that we can test on before they'd be deployed in those scenarios. And with these models, they can be trained on the corruptions so that they won't fail in deployment, because fundamentally that is what we want to avoid. We have autonomous driving systems, we have drones that all rely on these, and a failure in those systems is a safety risk to the public. So the work in data augmentations and making the models robust from the get-go before deployment is really key in adding to the safety of everything. And in the future, hopefully more work can be done with these augmentations and with the robustness of models, whether it's through the actual layers or, like my project, through the data, so that we can have safe models and safe computer vision systems as we move into a future with more and more of them being applied. Thank you.